Hey everybody, so this is going to be an introduction to assignment 8, which would be our digital site model assignment. So for this, we're going to use the elevations that were drafted in assignment 7, as well as the provided GIS information in Rhino and Google Earth Pro to create simplified building volumes for the neighboring buildings and the general context around our site that we're going to be using in Studio. Each of these are going to be made into a series of simplified blocks that will be able to be distributed to each student, so we all have a full site model that could be referenced into our own Rhino model, so we can have that as context as we're designing. So in general, what we're going to be creating are going to be very simple, solid volumes that represent both the sort of simplified footprint of the buildings. We don't have to be too exact here, but we should try to be approximate whenever possible. Also representing the sort of pitch of the roof and the general shape of the roof, again, in a sort of a simplified approximate form. Don't have to be too specific here. Again, we're just trying to get an idea of what this context looks like with as much accuracy as sort of reasonable, given that we're going off of, measuring Google Earth Pro, using Rhino GIS data and these sort of approximate elevations that we drafted up from photos. Essentially, once we've done this, we're going to have all these models that we'll create into blocks, and then we're going to, through coordination, bring them all into a single Rhino file that will be distributed to each student in this section so that you'll have everyone else's work as well as your own. Key to this is going to be proper layer management, purging your file of all extra line types and just everything, layers, line types, everything else, in order to keep file sizes small. So to that end, I've listed a series of 4 layers that you're going to be using. So in order to do this, though, it's best to copy and paste these new layer names in. So the elevations you've drafted so far, your heaviest outline, you want to use the heavy outline, and that's going to be your general building outline. And again, copy and paste this exactly. Any minor variation between layer names will end up becoming duplicates, and when we end up having anywhere between 13 and 17 different layers brought in as all of our models get combined, we end up with a lot of extra layers that aren't really necessary. So we want to make sure we're copying these exactly, and again, copy and paste is the best way to ensure that you do this. After that, we'll want to run a purge command and remove all of the extra layers. So when you're drafting, you might have included, say, vegetation, neighboring trees, street trees, whatever it may have been, a ground line. All of that stuff we want to remove. So really, we're only focused on the heavy outline, the medium detail, which will be sort of your window cutouts and things like that, and the light detail, which may have been your lintels, sills, cornices, columns, whatever it may be. And then the final one will be our 3D buildings, which will just be the 3-dimensional geometry that we create. And again, our focus is going to be simplified, solid objects that represent, broadly speaking, what the building is based on the best measurements that we can get from the information that we have. As you create these, you'll want to combine that elevation information you've already drafted with the model into a single block definition in this case, and you want to name this block. So when you create a block, it asks you to name it. Normally, in most circumstances, I just kind of hit whatever, just hit OK. It's not always the greatest practice. It's good to sort of name these things to keep organized. So in this case, just name your block with your last name and then underscore 00, 1, 2, 3, 4, however many of these you end up making. For some of you, you have between 1 and 4 different buildings that you might be creating. Again, they're all pretty simplified, so shouldn't worry too much about them being super exact, but you would want to keep organized by naming them correctly, just so we, again, can keep the file as manageable as possible. And then essentially on Thursday of this week, you'll work with your GA to try to combine all of these different files into one large file that has all the individual elevations that everyone has drafted and the building volumes with them. At that point, you'll also remove everything else. So you want to use the Rhino GIS information to correctly locate each of your buildings so that they are placed in the same location in each file according to the parcel that they should be placed on. But then once they have in place, we'll remove all of that extra information. So the only thing that's left in your file are going to be the 4 layers that are listed above, which are going to be your heavy outline, your medium detail, your light detail, and 3D buildings. Everything else we don't need for now, because we're going to reference this new file in that just has the buildings floating in space, but correctly located for floating in space, into our own individual Rhino files with all the original GIS information. And that way we can easily turn on and off the buildings and all of their context information within our new file and not have them contribute to the overall file size or slow down your file in any way, because we're going to use what I call Rhino work sessions, which sort of are a reference way to link in your files, very much like how InDesign links in files where Photoshop often will directly import files. So in this process, when we're making this sort of larger file that we're going to link in, we actually want to directly import all of the geometry. Now Rhino has 2 different terms, one of them import and one of them insert, that are very similar, but they do mean 2 different things. So in this case, import means bringing the geometry into your own file and combining them, so it's one singular file. The insert in this case is a little bit different, where it's actually more about sort of referencing, again, similar to what you'd be doing in InDesign, where you're referencing a file into another file. We're going to be doing something similar with another function in Rhino that's called work sessions, which allows you to reference sort of, generally speaking, larger amounts of information, although you could do it either way. It's usually used for referencing, say, other models into your model that are more complex. And that's sort of the value of what work sessions brings to us. And again, I'll go over this in the sort of demo, but that's the process that we're going to go through. So on Thursday of this week, you'll want to hopefully have these things modeled up, and then work with your GA to make sure that you can get them all into one model. Afterwards, once you have all of the models that your studio has made in one single Rhino model, what I'd like everyone to do is a sort of output for this assignment is essentially take a couple different street elevations, both on Liberty Street and Elm Street, which our site is on the corner of. So for these elevations, I want you to essentially create 4 elevations. On Elm Street, that would be the east and west elevation. So all the buildings that your section has created, their elevations looking east, all of them looking west. And then on Liberty, the same thing, just looking north and looking south. Okay. Now next, I'll just show you a brief example of this. Again, most of this will be covered in the demo. So this is a model I've showed in the past, and it's obviously for a different project, but this is our general goal. Now the site here, again, is much steeper than the site that we're dealing with, but I will cover how to create these sort of smooth surfaces out of topography lines. But you can see here, we have sort of simplified building volumes with the elevations in front of them. If I turn on print display, you can see here we actually have the line weights that are set up. In this case, the site for this project was this giant hole here. The hole was really unnecessary. It's just we weren't sure when designing this how deep we were going to go with the project with the various basements and everything. When this was designed, none of that had been sort of considered yet. But ultimately, you can see here that if we take a clipping plane, and I'm just going to make sure this clipping plane applies to all of my layers. Actually, I'm just going to turn it around real quick so we can see this side. But if we go to I'm going to set this to front view. Essentially, that will be our elevation. So we would just export this. Then we can see we have a street elevation. Now, again, since this particular project is on a street that is very hilly, you can see here that we can start to understand the relationship of these buildings to one another. Moving down the hill, so we can see here we can start drawing lines across and figure out how these buildings relate to each other. But again, let's pretend for a second that our site is this sort of infill piece here. We can look at the buildings on either side and understand that elevation information in relationship to our own site. So essentially for our own site, we're going to be starting with these sort of drafted things that currently just have the sort of elevation layers, the various layers we created, the photo, and ultimately taking that into a 3D form that looks something like this. Now this is all we're sort of looking for. Very simplified geometry, just representing what is there. So in the demo, I'm going to cover, again, how to do this process as simply as possible, how to geolocate. So this thing is located on the actual parcel that it needs to be located on and is oriented correctly to that parcel. So when we copy and paste this or bring this into another file, it will automatically be located in the exact location it needs to be, which will just be a big time saving for us. So with that, I'm going to end this and then we'll start the video for the demo. Thanks.